This is Mr. Precella with his Math 1324 Business Math class, and today we're going to be beginning our discussion of financial math with the simple interest formula. And the simple interest formula is the formula that most people, if you say, well, give me an interest formula, or the interest, they'll think I equals PRT. This is the simple interest formula. And let me go ahead and state these formulas. Simple interest formula. And this is the formula most people think of as an interest formula. I equals PRT. And this is where capital I, just like all formulas, unless you know what the variables stand for, the formula is worthless. Capital I is the amount of simple interest. P is the principal or the present value. It's the amount of money today that's being loaned today or that's being invested today. I'll call it present value or principal. R is the stated interest rate. Stated rates are stated as annual rate. It might be called the stated rate or the nominal rate. It's the interest rate that's given in the problem. And T stands for time, parentheses, in years. So, if you were told that the person borrowed money for 6 months, T would not be 6. It would be, well, how many years is 6 months? Well, 1/2. You're going to have to, if you had months, you take the number of months, put it over 12. That'll make it into years. Or let's suppose it said days. To convert days to years, you would divide by what? How many days are there in a year? 365? Now, here's the tricky thing. Sometimes banks or financial institutions will use 360 days. So generally the problem will tell you which one you're using. My rule of thumb is I use 365 days in a year unless it specifically says use 360. Okay? Back in the day before computers, the calculations were easier for banks. Imagine when it was all done by hand. Like say it's 1800s, and they were calculating interest by hand. It was a lot easier using 360 than 365. So some banks still do that, use 360 just sort of as a habit, although by no means are there any banks or financial institutions that aren't calculating interest with computers. Okay? So, number 1. It's number 1. So, find the simple interest on $35,500 at 11.25% for 127 days. And then it says, assume 360 days in a year. So this one's telling you assume 360. Well, notice simple interest loans are usually used for short-term loans, or if you were maybe loaning money between friends and family. That's a trick I never learned on how to make friends or family pay interest on money you loan them. But if you're firm enough and can do that, Generally, if you're loaning a friend or family money and charging interest, it's simple interest. But if you can take some advice from me, generally, if you loan money to friends or family, if you can get it back at 0% interest, then you're doing really good. Or if you're like a Swiss bank account charging negative interest, if you can get it back with a little negative interest, which means get back less than what you actually loaned, you're doing pretty good when you're loaning money to friends and family. So it's just a straightforward I equals PRT problem. I is what you're trying to find. So when we're doing these financial math problems, I'll generally identify the variables. P, that's the principal or the present value, the amount of money that's being borrowed or invested today. That's $35,500. R is that stated interest rate, 11.25%. Don't write 11.25%. Instead, convert that to a decimal, 0.1125. And T, don't write 127. That's going to assume 127 years, not 127 days. So to convert it to days, you go the number of days divided by 365. Or in this case, we're told 360, so 360. So I equals 35,500 times R times T. Well, I'll use a calculator. Ooh, I don't have my calculator. I have to get one. So I'll just pull up a calculator on my phone. It's nothing real fancy, but 35,500 times 0.1125 times 127 divided by 360. And I'm showing $1,408, and it says round to the nearest cent. So, ooh, it's sort of hard to see this. It's written in green, 0.90625, so 0.91. So 1,408.91 is the amount of interest on this either investment or loan. Okay. Let's state a few more formulas before we go on and do another problem. We already have these interest formulas, or this interest formula, I equals PRT. I'm now going to state one for what's called the future value. If we look back at this problem right here, the simple interest is $1,408.91. If this were a loan, a simple interest loan, the amount of money that the person would have to pay back would be the $35,500 plus the $1,408.91. It's getting sort of loud. Let me shut the door. So I'm going to write a formula now for future value. There's some more formulas that go with these two here. A equals, let me straighten up this paper, P plus I. And this is where A stands for the future value. If you took out a loan today, the amount of money, a simple interest loan, this isn't like a car loan where you would pay money every month, or a house loan. This is if you just went and borrowed a small amount with the intention, I'm going to pay it all back in a few days. And when you do pay back the loan, you would be paying back the principal, the amount of the loan, plus the interest. So formulas that you need to know to work these problems. Here's one of them. I equals PRT. Here's another one. Future value equals present value plus interest. And then there's a third one, which I'm going to derive now. So bear with me, I'm going to derive another formula. If I replace this I with PRT, I'm now going to do a little algebra. If I factor this capital letter P from each one of these terms, y'all remember how to factor a variable out of something? P times 1, P times 1 will give you a P. P times a RT would give you the PRT. By doing that, we can now solve for capital P. Just divide both sides by 1 plus RT. So here's a formula. P equals A over 1 plus RT. This formula can be used to calculate the present value if you know the future value, the stated rate, and the length of the loan. To work these problems, I'm going to get them all done using only these three formulas. I equals PRT, A equals P plus I, P equals A over 1 plus RT. Now, let's look at problem number 2 right here. Problem 2 says, right there, 2 and 3 are very similar. Okay, problem 2. Find the present value of the given future value. Well, here we're told a future value. We need to find the present value. So this problem right here is a direct application where I can use that formula I just derived, this star rule. P equals A over 1 plus RT. The A, let's go ahead and write out and identify the variables. The A, the future amount, is 18,000. The R, the stated rate, 5%. And T is 13 months. But wait a minute. I'm not going to write 13, or else that would be 13 over, that would be assume 13 years. I'm going to write it as 13 over 12. So to plug in here, I have P equals A is 18,000 over 1 plus R times T. Now this stuff gets sort of tricky when you punch it into your calculator. If you want to get the right answer, you're going to have to tell it calculate that bottom first. In general, if there's more than one number on the top in a fraction, it's best to enclose it in parentheses If there's more than one number on the bottom, it's best to enclose it in parentheses. So, it's going to loan me a calculator. So let me see. How would I punch this in? I know it's a glare. I turn this on. Ooh. That's not bad. Okay. So I'm punching this in right there. 18,000 divided by, open parentheses, 1 plus 0.05 times 13 divided by 12, enter, $17,075, and I'm assuming we're rounding to cents, 0.0981. Would that be 10 cents? Oh, but wait a minute. Here's a classic example. You got to read these instructions. It says round to the nearest dollar. So the number you're going to punch in there is $17,075. If it had been 50 cents or more, we would have rounded. Oh, I'm sorry. 50 cents or more, you would have rounded up. This is an example where I'm using that P equals A times 1 plus RT formula. This one here. You use that if you know the future value and you're trying to find the present value. Okay. Number 3 is the same type of problem, but this time A is 21,283. R would be 0.085. You're going to have to get used to writing these interest rates as as a decimal. And T is not 156. It's 156 over 360. Three is very much like. So I'm going to write, oh, there it goes. Lights in this room. Today's just been going crazy. It goes off every 2 or 3 minutes, it seems like. A, 21,283 over 1 plus R times T so to punch this into the calculator. Oh, right there. Okay. Right there. Oh, okay. I got to remember. That's where I need to put my calculator. So 21,283 divided by, open parentheses, 1 plus 0.085 times 156 divided by 360. And there's another one that says round to the nearest dollar. So how would I round this? 20,520. Do I leave it as a 6 or round it to a 7? Well, round it to a 7, right? Because that would be what, 92 cents after it? So $20,527. Now, over here, and let's see, what does number 4 say? Doing this one right. Oh well, I'll just have to move it out. Now we're ready to do problem number 4. Problem 4 says a student borrows $6,000 15% for 3 months. Find the total amount due. So this person's just borrowed $6,000 at a really high interest rate for just a short period. Then in 3 months' time, he's paying it all back. The $6,000 plus the interest. So this is going to be a problem where we do more than just calculate the interest. We've got to find the future amount. How much must be paid back in the future? So we're going to have to calculate the interest and then add it to that $6,000. So I'm going to first find I equals PRT. So in this one, I'm first finding the interest, I. P is 6,000. R, the stated rate, 0.15. And T is 3 months. I'm not going to write 3. That would be 3 over, I would assume 3 years. So to convert 3 months to years, it'd be 3 over 12, which if you want to reduce to 1/4, isn't 3 months 1/4 of a year? 3 months is a quarter. So now to punch this into my calculator, oh wait, I have it actually written out when I'm punching in. So here's what I've got to punch in. 6,000 times 0.15 times 3 divided by 12. I should be able to just punch that straight in as it's written. Okay, I'll just clear that. 6,000 times 0.15 times 3 divided by 12, 225. That's the amount of interest that's going to have to be paid, $225. But the total amount due in 3 months isn't $225. This student has to pay back the $6,000 plus $225. So the amount of money that has to be paid back is $6,225. Okay. So you first calculate the interest and then add it to the present value. So you were using this starred rule right here. Future value equals present value plus interest. Okay. Let's try this next one. I just printed out some examples like what you'll encounter in your homework, and that's what I'm working right now. Let's see. Number 5. An account invested in a money market fund grew from $73,245.22 to $73,537.30 in 1 month. What was the interest rate to the nearest tenth? So this one's a little different because you're going to have to find the interest rate. So I'm going to break this up into a few pieces. First thing, if it grew from this amount to this amount, how would I calculate the amount of interest that was earned during that month? The amount of interest earned would be the future value minus the present value. So I'm just going to write this out to show my thoughts. Here's how much it was at the end of the month. Here's how much it was at the beginning. So the I'm just going to punch those numbers in. $73,537.30 $537.30 minus $3,245.22. That's $292.08. So at this point, I've figured out capital I, that is simple interest. Do we know the time? Well, yes, 1 month. So I'm going to use I equals PRT. And this time I, we know it. It's 292.08. P, that's the amount of money at the beginning. That would be the $73,245.22. R, the interest rate, is what we're trying to find. T is 1 month, which we don't write as 1, we write as 1 over 12. So lowercase of this R here is what we're trying to solve for. You'll notice at times I might be saying capital I or lowercase r. As we continue this discussion of financial math, there's going to be some formulas that have a capital R, which is different from a lowercase r. There's also some formulas that have a lowercase I, which you can sort of guess is different from a capital I. That's why don't start changing your cases. Okay, by that I mean don't write this lowercase r with a capital R, because that capital R is going to mean something different in when working with some of the annuity formulas. Okay, so we're trying to find R, so I'm going to do a little not calculus, algebra. I equals PRT. If I want to isolate that R, I would need to divide both sides by PT. So here is what I'm going to substitute into. R equals I divided by PT. So I'm now plugging in. R equals I is $292.08. P is this $73,245.22 times T 1 over 12. If you have just one number in the numerator of a fraction, you don't need that in parentheses. But here I have more than one number there in the bottom, so I better put those in parentheses to make sure I'm telling the calculator, you do that whole bottom before you actually do the division. So, I lay my calculator right here. I'll clear that. 292.08 divided by parentheses $73,245.22 times 1 divided by 12, close parentheses, enter. We get a long decimal number. 0.04785,240. Now remember, we're looking for an interest rate, and it wants us to write it as a percent. So we need to write it as a percent. Don't round until your final answer, it says. So if I were going to write this as a percent, I would need to move the decimal point, or write this as a percent. I need to move the decimal point 2 places to the right. Basically what I'm doing is multiplying by 100. Y'all see that? So I'm getting, as a percent, 4.78524 ... Let's see how it tells us to round. Move the calculator. It says round to the nearest tenth as needed. So once you have it written as a percent, now it's where we round. Nearest tenth means one digit after the decimal point, right? So this would be a 4 point, leave it as a 7 or make it an 8. I would make it an 8. 4.8%. Okay. Any questions there on that? You're following what I'm doing? Number 6. Let's do that one. Dave took out a $6,000 loan at 13%, and he eventually repaid $8,340. That's the principal and the interest. This is a typical short-term loan. You don't make monthly payments on it like a car loan or a house loan, okay? This person, Dave, took out a $6,000 loan, 13%. He paid back $8,340. What was the time period for the loan? Well, I'm going to do this problem like number 5, at least to get started. I can calculate the interest here by subtracting the future value, the present value from the future value. The amount of interest would be $83.40 minus $6,000, which is $23.40. That's the amount of interest he paid on this loan. We're told that the rate is 13%. We want to know the time period. Okay. Well, if I think of I equals PRT, which variable do I need by itself? Which one am I trying to find? Well, I'm trying to find T. So I'll divide both sides by PR. So here's the formula we're going to be using. T equals I over PR. Now I is 2340. Is this reading showing up okay? Yeah. P, well wait, I didn't write out what P was. P is that present value. So that's the initial amount. How much was the loan for? Which one of these dollar amounts is going to be P? The principal or the present value, whatever you want to call it. It would be this one. The 8340, that's the future value. That's the principal plus the interest. So we go 6,000 times R. Plug that into your calculator. I'm going to put the 6,000 times 0.13 in parentheses. So, move this. Turn it on. Let me clear all of that. So it's 2340 divided by parentheses 6,000 times 0.13. Oh, that's a nice even number. Oh, not all even, but 3. So the time period for this loan was 3 years. Okay. Any questions there? So that was a sort of long time period for a simple interest loan, but maybe it was a loan between family members or friends. Okay? Generally, banks aren't going to use simple interest loans unless the time period is relatively short, less than a year. Okay? So the time period for the loan was 3 years. Y'all following what I'm doing? Let's do the next one. Number 7. Let's see. Tuition of $1,633 will be due when the spring term begins in 7 months. Okay, so tuition's going to be due. What amount should the student deposit today at 3.54% to have enough to pay the tuition? Okay. The amount of money is $1,633. That's I'm going to draw a money timeline. That $1,633, that's a future amount. Oops, 1633. That's how much money is due when the spring term begins in 7 months. What amount should a student deposit today? See, in this particular problem, you're trying to find capital P, the present value, at an interest rate of 3.54%. So this person's going to set aside money so that he has enough money to pay the tuition. Maybe a wealthy relative gave him some money, maybe $5,000, and he's like, I'm going to go blow that money, but first I want to set aside enough money to be able to pay for tuition next semester, okay, or in 7 months. Well, how do we do that? Well, notice, look at the amounts that are given. This $1,633, that's a future value. You're trying to find the present value. We've done a problem like that, or maybe 2 like that, where we knew the future value, we're trying to find the present value. This one is an application. This problem we're doing is an application of that P equals A times 1 plus RT formula. The future value is $1,633. R is 3.54%. I'm not going to write 3.54. I'm going to write 0.0354. And then the time, T is not 7. It is 7. Did y'all hear that? 7 over 12. Okay. So times 7 over 12. You're going to have to punch that into your calculator. Do I need to put parentheses around something? Yeah, that bottom there. Okay, so let me move my calculator in. Follow this over. Let's see how bad is the glare. Well, it's sort of visible. Okay, I'll go 1633 divided by parentheses 1 plus 0.0354 times 7 divided by 12, close parentheses. So he better put aside $1,599 and what would y'all say that is? $1,599.96. Wait. Oh, wait. We're told to round to the nearest dollar. So that 0.9608. If I'm going to round that to the nearest dollar, that would just be $1,599 or make it $1,600. Well, $1,600. So he needs to put $1,600 he or she is to put $1,600 into that account, and then in 7 months he'll have his $1,633 to pay for the tuition that he needs. Okay? Oh, let me move this over. Okay? I'm just working some problems dealing with simple interest. And you notice how I keep saying simple interest. If you may have heard the phrase compound interest, so that's why we distinguish between simple interest and compound interest. Simple interest, the interest is being calculated only one time during that time period. Well, what if your interest is calculated more? Like most banks, if you go put money into an account, every month they calculate interest and add it to it, so you have a little bit more interest. That's an example of compound interest, which is what our next topic will be, okay, after simple interest. Let me flip through. See, Carl Yates. We're going to do the Carl Yates problem now. Carl Yates needs $24,000 to pay for remodeling work on his house. A contractor agrees to do the work in 10 months' time. How much should Carl deposit at 5.3% in order to accumulate $24,000 by that time? Well, if we draw a little money timeline, that $24,000, that's a future amount. That's how much he's going to need in 10 months to get that work done. We need to find out how much he should deposit today, the present value. Well, we know the future value, A. We know the time and the stated rate. So which formula would we be using here? Have we already done something similar to this? Well, yes. You know the future value, the rate, and the time. You need to find the principal or the present value. How much should he deposit today? So A is 24,000. The stated rate, 0.053. T is 10 months, but we write it as 10 over 12. If you write just 10, it's going to be 10 years. So that house remodeling isn't anything really crucial, is it? Now, plugging in, P equals A over 1 plus R times T. So I'm going to punch into my calculator. Turning it on and clearing it. I know there's a glare. 24,000 divided by parentheses 1 plus 0.053 times 10 divided by 12, close parentheses. Get into the habit, if you open parentheses, close them. Even though on this particular calculator, if you don't close them, it'll still count it right. Or it'll still give you an answer. Some calculators make you close those parentheses. If you don't close them at the end, it's going to say error. So I'm assuming we're going to round this to the nearest cent. Round to the nearest cent. So that would be a 0.83 or 84. 83 cents or 84 cents? Looks like 84 cents, right? So Carl should deposit $22,985.84 in order to accumulate $24,000 in 10 months' time. You should check and make sure that your answers are sensible. If you had pulled up some number bigger than 24,000, I'm always amazed when students on a problem like this answer something like $15 million or $7 billion. They didn't understand the problem. How much should he deposit? It better be less than 24,000. Okay? Any questions? If you're thinking about it, seems like we're using those same formulas over and over, but yes, we are. Okay? Yes, we are. Let's see. What about number 9? What's number 9? Well, an accountant for a corporation forgot to pay the firm's income tax. We're doing this next one. Oh, that accountant might get into trouble or might get fired after this. An accountant for a corporation forgot to pay the firm's income tax of $725,878.96 on time. The government charged a penalty of 8.7% interest for the 45 days the money was late. Find the total amount, tax and penalty, that was paid. Assume 365 days in a year. Oh, so this one's doing the right number of days, 365. Okay. Well, what are we asked for? Find the total amount, the tax and the penalty that was paid. Okay. See, he's got to pay the corporation has to pay this much back. So what we need to do is figure out that penalty, which is just an interest problem. I'm going to find I equals PRT, and whatever I have, I'm going to add it to the $725,878.96. That's the principal or present value. The R, 8.7%, that's a 0.087. And the T is 45 days. Don't write just 45, or it'll assume 45 years. Can you imagine what sort of tax penalty that would be, 45 years late? So you divide by 365 to turn that time into years. So we move over. Get my little calculator here. And turning it on. Clear this. $725,878.96 times 0.087 times 45 divided by 365. So here's the penalty. $7,785, and I guess we'll round this to the nearest cent. Would that be 80 cents? 0.797, yes, 80 cents. So now we're going to add. Here's the penalty, $7,785.80 plus amount of tax, $725,000. Ooh, it's getting hard to see it. $725,878.96. So how much are they going to have to pay? The tax plus the penalty, $733,000. $664.76. Any questions there? We'll do one more. These problem number 9. Excuse me, number 10. Open my calculator. Mary Branson invested her summer earnings of $3,000 in a savings account for college. Oh wow, Mary Branson, she's setting a very good idea and learning good money management strategies. So she puts her summer earnings of $3,000 in a savings account for college, and unfortunately today's savings accounts don't pay much, paying 1.5% interest. How much will this amount to in 9 months? Well, we need to know that future value, so here's what I'm going to do. I'm going to first calculate I, the simple interest, principal times rate times time, and then I'll add that to the 3,000, and that's how much she'll have in her account after 9 months. So I equals 3,000 times 1.5%. I'm writing that as a decimal, 0.015 times T. Don't say 9, because that would assume 9 years. Write it as 9 over 12. So I'm going to punch that. Right up there, 3,000. Oops. Move over a little more. 3,000 times 0.015 times 9 divided by 12. So $33.75. That's the amount of interest that she'll earn on that money. And so how much will be in the account after 9 months? Well, not $33.75, but the 3,000 plus $33.75. So I'm adding the 3,000, and here's the answer. $3,033.75 is in the account after the 9 months. Now, you might be thinking, well, that's not much interest. Yes, but she has the 3,000 too. Let's not forget that. If she'd just gone and blown the $3,000, she wouldn't have anything. Okay? So don't forget that she has that principal. Whenever I'm making money management decisions, my idea is always preservation of capital. I have a friend that's an economist that says, oh, please don't tell your students that. But my idea is always I want the money invested in such a way that I don't lose it. Now, the rest of the problems I've printed out, we've already done something like the student borrowing the money and another Carl Yates. These might be things that you'll see on your homework. Sometimes you'll just find the same problem popping up more than once. Look at this. My number 12, Carl Yates. But it has different numbers. It's very highly unlikely that it would ever just pop up as the exact same problem with the exact same numbers and everything. Okay? Dave took out a loan. Have we already done Dave taking out a loan? I think it was over here, number 6. So I think I've done enough now for you to really make good progress on your homework. The next time we're going to continue our discussion of financial math by discussing the compound interest. So it's important that you stay caught up with me, okay? Don't get too far behind, especially if you're listening to this in an online class. You know, it might be tempting to delay and not get it, you know, I'll do it another time, but try to stay caught up with me, okay? Because this stuff is going to be, especially this financial math stuff, it's going to all be building, okay? So the next topic is going to be compound interest, and I will talk to you soon. Okay? Bye-bye.